Draw the diagram. Then I'll come into the picture. At least minimum a student should try to draw the diagram here. I think I'll 3 situations are there. So let me take it here. Yeah. See all these chamber problems, what is the method? Somehow what happened, we should understand the situation given. The rest of everything, writing equation, they'll be much easier. Only thing is we have to put effort in understanding the situation and identifying what process the gas will undergo. Once you get that, I think we can manage and there won't be that much of difficulty. So initially, okay, there's a piston. This is the thing. So where is air now? So let me read the question. So here is what gas is present. I'll show like this. This will help us a lot. The cylindrical vessel shown in figure has 2 pistons in it. The piston left touches a spring attached to a wall of vessel. The wall has a hole in it. The volume of air between the pistons is volume of air. Okay, here initially some volume is there. Let me call that as V1. This is the thing. Okay, now this is like this. So this is a hole. What do you expect here? Pressure will be atmospheric pressure, and the pressure is initially equal to external atmospheric pressure. So here pressure is P naught. Now also pressure P naught. And what is the state of spring? Will be relaxed, or will it be compressed? Anybody? Should be, because P naught S force will act. And what is the state of spring? Spring will be relaxed. Okay, now what we do is going to, the piston on the right is slowly pressed inwards, maintaining constant temperature until its inner surface is at the piston where the inner surface of piston on the left was initially. So you will now displace in such a way that it will come to this position. There's a question. What happened to this piston now? The purple color piston. So it should get shifted. Okay, it will get shifted. Okay, let's assume. Let it come here till here. Now what is the state of spring? Spring will be compressed. So there's a gas now. See, we have to understand there's no other way. There's no other way. First, we'll understand what actually goes on. Then we'll get into the problem. Okay, after this. Until its inner surface, what will be the final volume of the air between the piston. The cross-section area of the cylinder is 100 centimeters square and the force of 10 Newton compresses the spring by 1 centimeter. With this, we'll get the spring constant. Now also, what will be the pressure? Okay, now what will be pressure here? Will be air, because air will be present here, air atmosphere. What is the state of spring? Compressed, elongated, what we can say? What will be the final volume of the air between the pistons? So the final volume we don't know. The pressure, let it be P. Maintaining constant temperature. Maintaining constant temperature. What are the forces that are acting? P naught S, PS, then spring force. Okay, I think this much is what I'm able to write it. What to do now? Okay, I think the last diagram not needed. I'll take it off. This not needed, no? Delete it. Yeah. What do you expect this length of this chamber? Let it be X will Celtic. Because if the spring compressed by X, then definitely this should be the X net one. Will I agree? This is very important. How much piston the purple color piston has undergone displacement, that much the spring has undergone compression. Agreed? Okay, let's write. What is the state of this? This is in equilibrium. Okay, we'll write equation now. P naught S plus Kx equal to Ps, where S is the area of cross section. What process the gas will undergo? The air will undergo between the pistons. Temperature constant isothermal process. So therefore, what we can write it as? P naught. What was the initial volume? The volume of air, V naught, no, it is, I'll change it. V naught, okay, this one P naught, V naught is equal to P into V. So initial pressure we know, initial volume we know. Okay, fine, and let me write here. What is the final pressure? Final pressure will be P naught S plus Kx by S. What is the final volume? Final volume will be S into X. So what we should calculate here? So P naught, V naught, P naught plus Kx. I think that's it will be like this, huh? One S will get cancelled, no? So P naught Sx into Kx square. Solving for X, X is a unknown thing. We'll calculate X. Once we get X, what will be the final volume of the air between the piston? What is the final volume? V equal to S into X. So there's a quadratic equation we have to solve. So Kx square. Question is very simple unless we will understand it. X will come if you solve it approximately. This is approximately. Then substitute that, multiply with area of cross section. It is in cubic centimeter. You'll get the required answer. Okay, this one. Okay, let's take the next one. And this is some